All right, campers, this is Unit 4B, Lesson 9, the Mole Calculation Lab. Here is what we're going to do. We have about 20 of these little flasks right here, and they have different elements in them and compounds, molecules. So we are going to work with those. Here's what I want you to do. I'm going to do one for you, and then you're going to do the other 19. Now, here is what we're going to do with the flasks. We're going to take each one of them, and it has a substance in it. This one has carbon. Hopefully you can see that. I'll write in red on this so you can see. You will need for this you'll need your periodic table, and you will need a calculator. The name of this substance, we're going to give you the chemical formula, so in this case, this is C. Hopefully you know that that's carbon. And then you are going to get a gross weight. I am going to place it over here on the scale and get a reading, and this one happens to be 29.201. And I will put those on a card for each one of them. Put it down here so you can see it. So sample 1 is C, which is carbon, 29.201 grams, and that is the gross weight. The gross weight means that the flask and the stopper is in there, and it weighs 28 grams. To find out what the sample weight is, you have to subtract 28 grams from 29.201. When you work it in your calculator over here, that will end up being 1.201 grams. Okay? From there, we write that down. So this is our sample weight after we get rid of the gross weight. We now need the periodic table because we need to know how much 1 mole of carbon weighs. And if we look at carbon over here, it is 12.011. 12.011. We put that in this column. This is on your Canvas sheet. You can print this out. If you can't print it out, just write this on a regular sheet of paper as best you can. We will turn that in when you guys come back to school next week. Now, 1 mole of particles, that is Avogadro's number, which is 6.02 times 10 to the 23rd. That's the number we need. We ought to make a rap song about that. 0.5 molar, how much does that weigh? It is going to weigh half of 12.011. When we run the numbers on that, we will get 6.005. Okay. How many particles are in half a mole? It's going to be half this number. If you take half of Avogadro's number, half of 6.02 would be 3.01 times 10 to the 23rd. And then it asks how much 0.1 moles weighs. And 0.1, we go over here, 12.001. If we move that decimal one place over here, we get 1.201. That's how much that weighs. How many particles are in that? We move this one place and we're going to get 0.602 times 10 to the 23rd. How many moles are in the sample? Here's your sample, 1.201. It's going to match one of these three numbers, either the 1 mole weight, the half mole weight, or the 0.1 or 10th mole weight. In this case, it matches the 0.1 mole weight, so how many moles are in the sample? 0.1. You're going to do that for each one of these. Some hints. The name of the substance from periodic table is carbon. We'll put that over here. And we're done with carbon. There are 19 others. Some of these are compounds or molecules. For instance, this one, NaCl. So you'll need to Google what NaCl is. I know that that's salt, but you'll need to figure that out. Okay, from here, I am going to put each one of them up here and give you the weight and the chemical formula, and then you'll figure it out from there. Here we go. Number 2. Number 2 is Cu, happens to be 29, that's a hint for your periodic table. We weigh it over here, and we get it with the flask and the stopper. It's 91.546 grams. That's number 2. Number 3. Number 3 is this shiny metal, and it is Al. The number happens to be 13. We give you that on some of them. I weigh it over here, and I get 41.491 grams. Remember that that includes the 28 grams for the flask and stopper, so you're going to have to subtract that out of here before you start working your calculations. That's number 3. Number 4. Number 4 is PB, and PB stands for lead. A plumber, that they got their name because plumbers originally worked in lead, and when we weigh that, we get 48.72 grams. Okay. That's number 4. Number 5. Mg, and we weigh Mg, and Mg weighs 40.152 grams. That is number 5. Number 6, Zn. Zn, you go, and if you look at number 30 on the periodic table, that is zinc. It weighs 34.54. Yep. Don't know what that says, but don't worry about that. Use 34.54. Sample 7. Sample 7 is right here. This is Fe. There's a little bit of it in there. Fe stands for iron. If we left that out in the open, it would rust, forming iron oxide. We weigh all this. It weighs 83.845 grams. That is sample number 7. Number 8. Number 8 is this white stuff right here. Your bones are made out of it. You get it from milk when you drink milk, so drink your milk. Calcium, sample 8, weighs 48.039 grams. Remember, that's the gross weight. You got to take that number out of it. That's number 8. Number 9. Number 9 is H. You should be familiar with that. We use it all the time. You weigh it with the stopper and the flask, and you get 38.079. That's number 9. Number 10 is another one of our old friends that we use all the time, and this sample is O, or oxygen. The arrow that goes up means it's a gas. If it goes down, it means it's a precipitate or a solid. And anyway, this is oxygen. Our sample gross weight with this included is 29.599. That's 10. Number 11. Number 11 is our old friend. You have it for lunch sometimes. You put it on your food sometimes. NaCl. This is a compound, so you're going to have to look up the molecular weight for Na and the molecular weight for Cl. Add those together. Subtract that number from this one to get your weight, and it weighs 33.844 grams. That is sample number 11. Number 12. Number 12 is the wild card. It's a little different because it has large molecules in it. This is C6H12O6, the flask and stopper in this case, please. This is the exception. See it down here in red? It weighs 150 grams. So, plan accordingly. The whole thing is 208.15. Subtract the 150 out. That will give you how much C6H12O6 you have. That's number 12. Number 13. And 13 is H2O2. If that's in your house, it'll be in a brown bottle. And you use it sometimes. You can brush your teeth with it. You can put it on wounds and it cleans them out. This whole thing together weighs 31.401 grams. Figure it out. 14, we are heading a little closer to home. 14 is this good stuff, NH3. Everybody knows that I use this in the lab all the time. It stanks, but it's good stuff. It kills bacteria, fungi, and other things which could invade your body. So, NH3, our gross weight is 45.031. Do your thing, campers. All right, the last 5, HCl. HCl is a very common acid. It is used in chemistry. AQ in there means it is aqueous. It is in water. It is an aqueous solution. So we have 31.646 grams. That's the gross weight. So that's 15. Number 16. 16 is our good old friend H2O, and you should know all about H2O. It is aqueous, of course it is, because it is water. H2O, the weight of it is 208.15 grams. That's pretty heavy. So, figure it out. 17. Sample 17 is C3H6O. It's right here. It is aqueous, so we have it in solution. And you will need to figure that out. It is 86.08 grams. And if you will Google C3H6O, you can find out what the name of that is. That's 17. 18. C3H8. This is important. We heat things with it when we go through combustion. So C3H8, and our gross sample weight is 50.048 grams. 19, we're getting close to the end, crew. CH4, it's right here. The arrow up means it is a gas. That's why there's nothing in there and it's not full of that gas. This is just an empty flask. It is just a placeholder. CH4, 29.604 grams. That is the next to the last one, and however, this is the last one. We've been looking for this for a while. It's right over here, and it is CO. This is carbon monoxide. You will have in some of your houses, actually should have them in all of them. If you'll call the police or in the fire department will come and check those for you. I know because my son works for the fire department. Carbon monoxide, the gross weight, 308.1 grams. Okay, you can go back and catch these if you need to. You can pause and all that good stuff. Take each one of them, put them on this lovely sheet that we made available for you. The first one's filled out, so each one of them, 2 through 20, write down the formula, the gross weight, subtract out the flask and stopper. Use the periodic table, figure out how much 1 mole weighs. This is going to be the same, here's a good hint, for every one of them. So all the way down that column, it's going to be Avogadro's number. Half of it is, this is going to be the same all the way down. 0.1 is going to be the same all the way down. This will be the change over here, this last one. How many moles are in the sample? That will change each time. Okay, that's it, guys, and we will see you later. Bye.